Hi there, I just wanted to go over some things that we have to know for our first test. This is really all about integrals and using application a little bit, just very slightly on Miss O'Brien covered when it came to approximating the area underneath the curve. So we have something on the left called LRAM. Uh, these are our Riemann sums, and the big deal about Riemann sums is just adding up rectangles to figure out how much area or how much how much I guess the area, but the accumulated change is probably what Mr. Bryan called it. So my problem is given here. If we go ahead and graph our x squared, negative x squared plus 2x plus 10. If x is 0, we're at 10. Oops. 0, we're at 10. Right, did it again. X is 0, we're at 10. If x is 1, we're at 9. If x is 2, we're at, I'm guessing it's going to be 6. Going the other way, 9 and 6. So we're parabola coming down. Now, we were asked to use LRAM, and LRAM, RRAM, and MRAM refer to a left, right, and middle. These are all, RAM stands for rectangular approximation. Method. And that's fancy speak for just draw rectangles. If I have the graph here, and I want you to ask from A to B, what is the area underneath that curve? What is the accumulated change of this whole section here? Well, if this graph was simply just a square, we would just say A to B, whatever the value, times the height. That's area of a square, a rectangle. We go B minus A, that's the base, and times H. So let's say this is 5, and this is, let's say 6. This whole thing would take up 30. Because it's a rectangle, easy peasy. But if you look here, a rectangle enough here, it's curved. So what they said was that, I know it's curved. So instead, why don't we draw little rectangles? Let me go ahead and use a different color here. And if I draw it using a rectangle, this rectangle would be, you know what, good enough. As long as everyone's, is on board, that is good enough. Everyone understands this is, for instance, this would be a left, LRAM. Now, how did I get LRAM? Why did I choose the points I chose? Let me go ahead and zoom in a little bit. So if I give you guys the same idea, and we'll pick 1, 2, 3, 4 spacings. If I chose the LRAM, so given a choice left or right, okay, and then the next problem with this will be left, and this will be right. And then our next point, this will be our left, then our right. And next point, this will be our left, and this point will be our right. Now, so every left and right point changes depending on where I'm looking at. For instance, the first rectangle is just this here. The second rectangle, third rectangle, fourth rectangle, oops, wrong color, third rectangle, and fourth rectangle. So given the first rectangle, I'm going to choose the left side or right side, left side or right side, left or right. If I choose LRAM, we use the left side. That's how we draw the rectangle. If I choose RRAM, and we stay consistent throughout the whole problem. Left or right, left or right. If I left or right, so the example for this problem is LRAM. So I'll choose the left side. 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 And those are 4 rectangles. Oops. So you can color it in just to show you. That's my first rectangle. My second rectangle. My third rectangle. And my fourth rectangle. This one's a little over, right? Which is fine. If I decided to use RAM, given these points here, we would choose the right side. I should draw it a little nicer. All these points all look the same. Whoops. So, draw lines. Right, right, right. For RAM. This is over here is LRAM, right? Okay, so for our first problem here, I asked you guys for LRAM. So if we look at the graph, we can label the points. It's from -2. Sorry. From -2 all the way to +2, we would end up drawing these 4 rectangles. Now for the first rectangle, I'm going to choose the left or right. We said left, so we use this point here to draw my rectangle. That's my rectangle. And so what's the base and height? The base is 1, the height is 6. So 6 times 1 is 6. That's my first value, my first rectangle. My second, LRAM, I'm going to choose L on the left, and that's my next rectangle. That's going to be 9 times 1. Why? Because the base is 1 here. That's the distance. Equals to 9. The next one would be either choose a 9, or 10 or 9. Left, we said specifically left. That's going to be a little bit over, which is fine. We were a little bit under before. That's going to be 10 times 1 is 10. And choose my left side, not my right. That's going to be 9 times 1 is 9. Add them all up. 15, 25, 34. And that is my approximation. The next problem here asks us, hey, using trapezoid method. Now, trapezoid approximation is drawing a trapezoid from it. So given a curved problem, let's pick a point here, one here. A square, no matter how nice the square is never going to be exactly matching that graph, right? We're always going to have a little excess. A little excess on top, a little excess on bottom. So if I just draw this out, if it was a left-hand approximation, we'd be a little over. Right hand would be a little over, a little bit under for left hand and a little over for right. And just to show you this, a little over, right? A little overage, a little under. So why don't we find a shape that would kind of cross between the two? And they tried a trapezoid. And that's a better approximation. You remember the area of a trapezoid is area is equal to 1/2 height b1 plus b2. But in this case, our b1 and b2 are going to be our heights, our y values. And the base here will be our height. This here will be our height. Now we're going to do that across our last graph. just going back here real quick, looking at it, we're going to say, hey, what's my trapezoid? What's my trapezoid? What's my trapezoid? What's my trapezoid? And we're going to do that instead. So let's go ahead and use our equation here to talk about that trapezoid. So our problem is going to be find that trapezoid approximation. So we're going to take our first value. Let's draw our first square real quick. Sorry. Let's draw the points. The points on the graph are going to be 6, oops, wrong graph. From -2 to 2, we want four trapezoids. 1, 2, 3, 4 trapezoids, right? And our spacing is going to be, the y values are 6, 9, 10, 9, 6. For trapezoid, the bases are 6 plus 9. The equation, remember, is 1/2 height. The height would be 1 because the distance here is 1. And our base 1 is 6, our second base is 9. And we're going to 1/2 that. Plus 1/2, 1 again, because the next value is going to be also 1. But the heights here are 9 and 10. Plus, sorry, I'm running out of space. Plus 1/2, 1 again. We're keeping our same distance. That's 1 over here. That's 1, right? Our heights are not 10 this time. 10 plus 9 plus 1/2, 1, and our last one is 9 and 6. Okay. So we form the area using trapezoids. And remember, this is an approximation. It's not supposed to be perfect, but it's supposed to give us an idea what, if we were just guessing, if we had to guess what our values would be. When you add this all up. Now, is that the fastest way of doing it? Answer, of course, is no. So, one of the fastest way is you go ahead and since they all have a 1/2, they all have a 1/2. There's a faster way: 1/2, 1/2, 1/2, and they all have the height is the same, right? The height is all 1. We write it instead. A faster way of writing it is 1/2 height. And let me see. We have on the top b1 plus b2 plus b2 plus b3 plus b3 plus b4 plus b4 plus b5. I have 2, 2, 2. We end up saying b1 plus 2b2 because we have 2 b2s. We have 2 b3s. We have actually 2 of all the middle numbers. 2b4. And we only have 1 of the beginning and last numbers. We only have 1 of the first ones and 1 last one. So we can do that quickly on your calculator. Of course, on our left, that is the basic way of understanding it, and it's pretty fast to memorize. And we're good. But if you want to do it fast, you do this on the right. Next question is, find the exact area underneath the curve. Now, to do this problem, we're going to go ahead and say the integral from a to b of f of x dx is the area for us, our cumulative change. Adding up all the parts. Now, the idea of Mr. O'Brien probably taught this to you guys. The f of x in a graph is your y value. And your dx is a little bit of x. When you multiply those together, that gives you our area. But dx for us is infinitely small. So we're really finding rectangles. Now the cool thing about the integral actually, as we use the word cumulative change, this big integral symbol is another way of saying look as a sum. It's actually adding. It's going to add all values of f of x times dx from a to b. And what this means, the integral will give us the area underneath that curve. Now, with our answers that we had before, well, we know it's about 34-ish, plus or minus. Well, what is the actual area? Let's go ahead. We write the integral from -2 to 2, and f of x, which is actually the y values, the function values of the graph, and dx. Now look at that problem. Do we know how to find the integral of a x squared, 2x, and 10 problem? Well, if we separate it into 3 integrals, this integral of -2 to 2 of negative x squared dx plus integral of -2 to 2 of 2x dx plus the integral of -2 to 2 of 10 dx. And if you want to write that, that's great, because that's really what we're doing in our heads. But please, it's a waste of our time. Let's go ahead and just take the integral as it is. The integral of x squared is negative x n plus 1 over n plus 1. Of 2x is 2x2 over 2 plus 10x. We're going to use this bar here to talk about a definite integral. We're going to plug these values in. We always go f of b minus f of a, f of b, meaning this is b on top, minus f of a, always in this order, if it's a. So we go to plug in 2, negative 2 times 2 times 2 is 8. 2 times 2 is 4. And 10 times 2 is 20. Minus. Plug in -2. -2 and negative is -8. Negative is positive 8. -2 is positive 4. Rewrite that. I didn't do it over here. It would be 2 times 4 over 2 minus 20, because -2 times 10 is -20. Then we do the math. -8 over 3. I have 2 of them, so that's going to be actually 16. Plus that's 8 over, this is going to be a 8 over 2. That's a -8 over 2. That cancels out. And negative is positive 40. Our final answer, rewriting this, is 40 minus 16 over 3. 16 over 3 is approximately 5 1/3. So this gives us, when we subtract it, it's going to be 34 2/3. Frozen the mess. How come I froze? Open that back up for a moment. There it goes. Um, 40 is equal to here 34 2/3, which is really close to what we had as an approximation, 34. This guy probably got us a little closer to that answer. And that's our answer. Okay, the next couple of questions here, I gave you guys actually a lot of practice because I am not sure Miss O'Brien went over this section. But what if I ask you guys to find, again, the left-hand approximation? Let's read the question. For each problem, use the left-hand approximation to approximate the integral based off the values in the table. Based on the values in the table. So the y values are 5, 5, 3, 5, 3, 5, okay? And the x values are 0 to 3, 3 to 5, 5 to 7, and 9, 7, 9. Now, it's kind of hard to picture this, so let's go ahead and draw it out real quick. The only time we're doing it. X is 0, 3, 4, 7, no, sorry, 5, that was 5, 5, and 9. Pay attention to how I drew this. I gave myself 0 to 3 is a little bit bigger than 3 to 5. Now, if I give you guys the values, the y's, that's going to be at 0 is 5, at 3 it's 3, at 5 it's 5, 7 it's 3, and at 9 it's 5. Now, if we're doing a left-hand approximation, that means we're gonna, given the choice for my first rectangle here, let me draw that again. For my first rectangle, am I gonna choose the 3 or the 5? Well, we said left, 3 or 5. We said left, right? So we're going this way. Between 3 and 5 for my next rectangle, that's going to be a 3, left hand. Between 5 and 7, we said left hand. And between 7 and 9, we said left hand. So that's going to be a little shorter. So what would the area be? Well, base times height, remember area is always base times height for us for rectangles. So it's going to be 3 times 5 is 15. That's my first value. The second part would be between 3 and 5, isn't that a 2? 2 times 3 is 6. Between 5 and 7, that is 2. And the left is going to be a 5. So 2 times 5 is 10. And the last rectangle, it's, remember that's value is 3. Do I choose 3 or do I choose 5? Well, we said left, so you have to choose 3. So that's going to be 3 times 2 is 6. Adding them all up, we have 16 plus 30, 16, 31, 37. Now, do you really have to draw that picture? Nope. That's the next problem, number 5, and you'll see we don't. The base of my rectangle is 1. Do I choose the left or the right? Well, 7 is on the left side of my rectangle, so use 7. 1 times 7 is 7. The next one, between 1 and 2, that's a 1. We choose 6, because that's my left side, plus 6. Between 2 and 7, that is 5. We choose our left side, that's 20. Between 7 and 8, that's 1. We choose our left side, that's 2. Approximation is 22 plus 13 is 35. Go ahead and try the other ones. Hopefully that was helpful. Now, we want to go through the integrals now. Now, the rule for here, this is fundamental theorem of calculus for us, is that if I take the derivative of an integral, they should cancel each other out. And I'm not quite sure if Mr. Bryan went over this. So I'm going to actually skip this for now. You guys let me know. Now we're going to take some indefinite integrals. Some fast rules here is, since that's a power, that's n plus 1. So it's going to be 8x to the 4, because 3 plus 1 is 4, over 3 plus 1 is 4. Let's break that down. So 8x cubed plus 1 over 3 plus 1. That's our power rule. Do the same thing for the next one. X squared. What happens to the 2? 2 plus 1 is 3, and we divide by that same exact exponent. Negative 3x cubed over 3. Write it out and then simplify later. And the integral of 5 constant is just 5x plus c. You can reduce this if you want. 8 divided by 4 is 2x to the 4th. 3 divided by 3 is 1x cubed plus 5x plus c. Our next problem, power rule, power rule, power rule. As long as that's not a 1, power rule. Negative 2 plus 1, negative 3 plus 1, negative 4 plus 1, x to the negative 1 over negative 1. Negative 2 plus 1 is negative 1. 10x negative 3 plus 1 is negative 2 over negative 2. And minus 15x to the negative 4 plus 1 is negative 3. Plus c. Our value here, our next problem number 13, it's negative 3 to the 1 over x. And if you guys remember, the integral of 1 over x is just natural log. You need to memorize that. Plus c, absolute value, remember the absolute value. Now, if I did try it, just again to reteach this, if if I did try to do the power rule here, -1 plus 1, -1 plus 1, -3, x to 0 over 0. Does that make any sense? Nope. That's why it's a natural log problem. Okay, you guys remember the integral of e to the x is always e to the x. So our rule is 4 integral of e to the x dx, because it's a constant, is just 4 e to the x. Please practice that. I see at exponential, the rule for derivatives, d over dx, that's a 3 to the x, is 3 to the x, natural log of 3. To go backwards, we have to get rid of the natural log. Okay, so the rule here is negative is a constant, 2 to the x dx is negative 2 to the x over ln of 2 plus c. That happens for any exponential, the base as a constant. Cosecant squared, that our rule is cosecant squared dx is negative cotangent x. So it'll be -4 integral of cosecant squared x dx is -4 negative cotangent of x plus c, or +4. You have to memorize your identities. The ones that are squared, only one that is squared is if it's cosecant squared or secant squared. Secant squared, integral of secant squared, just so yes and no, is tangent. Okay. Plus c, plus c. How do you know which one has a negative or not? Whenever there's a co in front of it, co's always give you a negative. Cosine, cotangent, cosecant, all of them give you negatives when you take the derivative or go take the integral. Okay, this one's easy. Cosine, integral cosine, if you want to rewrite it, is 2 cosine of x. Constants always can be removed out. 2 sine of x dx. Cosecant, cotangent, that's a rule for us. Cosecant x cotangent of x is negative cosecant of x. A straight identity. So it's 2 integral of cosecant of x cotangent of x is 2 cosecant of x with a negative plus c. Oops, over there, plus c. Messed up over here. Too fast. Tangent. Oh no, tangent. Tangent's a hard one because we don't have an identity for it. So this is when we start doing u sub, and the u sub here is integral of sine of x over cosine of x. And if I say u is cosine, if u is cosine, try it. U is equal to cosine of x, du is equal to negative sine of x, and then du and sine of x on the bottom. Hey, sine we get rid of. Sine and this sine will actually divide out. So we have to rewrite it. Integral sine of x, we said all cosines are now called u, and dx is du over sine of x. Don't forget the negative, which we're going to move to the front. Negative integral of 1 over u du. Hey, that's straight identity for natural log, right? Where our u value is going to be cosine of x. Let's see. Don't forget to plug in back your u value. Okay, number 20, we worked on this the other day. Please be aware that if I try u substitution, that's going to be 2x. Now, which is, we could try, we can't separate fractions because of that plus sign. That's not separating fractions. U dividing isn't going to help. So this is actually our inverse something. Inverse what? Inverse, inverse trig, inverse tangent This is just tan inverse of x plus c. Is it? Arctan. Okay, 21. Use substitution. U is equal to 4x to the 5 minus 5. So if you're not sure about u sub, just try it. Pick a sacrifice. I sacrifice 4x to the 5th. The derivative of 4x to the 5th is 20x to the 4th. Bam, that's going to get rid of it. When I move the 20x to the 4th over, du over 20x to the 4th equals dx. We rewrite it. Integral, we said x to the 4x to the 5th minus 5 is u now. We still had a... Wait, nicer if you guys can see it. U to the 5th, right? That's how we saw it. Times 20x to the 4th, that hasn't changed. And our dx became du over 20x to the 4th. Take a look here. Those divide out. And we're left with integral of u to the 5th du, which is power rule, u to the 6 over 6 plus c, which is rewritten as 4x to the 5th minus 5 to the 6th power over 6 plus c. Okay, this one u sub, same idea, u substitution. 3x plus 1 is our u. Du is 3 dx. dx, sorry, I forgot the squared. Because I forgot the squared, of course I took the derivative wrong. That was 6x plus dx. And we have we divide the 6x over, du over 6x. And look, that's going to divide out that guy. So integral of 6x, I'm going to write it out, u to the negative 5th. And dx, we always swap out our dx for du. And it's almost like when you switch dx and u, it's like you're switching currencies. If you ever got into Canada, you switch your $1 bills to loonies. And loonies and toonies. So we have to switch. So now we're all speaking in Canadian, eh? This becomes the integral of u to the 5th du. See, we went from x's to u's. And that's an easy power rule problem. N plus 1 over n plus 1. Integral of u to the 6, darn it, I don't know why I wrote that. Equals u to the 6 over 6 plus c, where we rewrite it as u is 3x squared plus 1 to the 6 over 6. This one is a hint. It's going to be a 1/2 exponent. This one over here, u substitution, try that. What's the derivative of tangent? That's going to be secant squared. That's going to get rid of that guy. Over here, that's going to be u sub, and the derivative of 3x cubed plus 4 is 9x squared dx. And if you look, this x squared and this x squared is going to cancel each other out. Sure, we have some numbers left over, but those are just constants. So go ahead, try it. Over here, let's say this is my u. U is equal to negative 1 plus natural log x over, and the derivative du is equal to derivative of negative 1 is 0, constant, and the derivative of natural log is 1 over x dx. And we move the x over, x du equals to dx, and this x would divide out with this x on the bottom. You're writing it, integral of negative 5 cosine of u over x, and our du became x du. And take a look, x is divided out, and we're only left with one type of variable. That's going to be our u's. And the integral of cosine is negative 5 negative sine, oh, not negative, positive sine of x dx. Oh, sorry, not dx, I'm sorry, plus c. Oh, darn it. Sorry, I keep rambling on. Our u value, that was a u value, right? I need parentheses here. And then the u value, replacing it, -5, sine, we said u was 1, -1 plus natural log x plus e. Okay. On the right, this is actually rewriting the problem. That if I try to use substitution, the derivative of 10 to the x is 10 x to the 9th. That doesn't get rid of the x to the 4th. So number 28 is a little tricky because you could try doing that. You could try doing long division. All of them would be for naught because you're supposed to realize this is a inverse tangent. How? No square root. Okay, so it turns out our u value, what do you think it's going to be? Remember, inverse tan is going to be integral of 1 over 1 plus u squared du. So that's going to be integral of 5x to the 4th over 1 plus u squared, where u has to be x to the 10. Nope, not 10. X to the 5. Du is equal to 5x to the 4th. X. Dx is equal to du over 5x to the 4th. Guess what? That's what it looks like. Integral of 5x to the 4th. Oh, let's rewrite that. I'm sorry. I wrote it there already. Let's go ahead and plug it in. Plug our dx in. And dx is du over 5x to the 4th. Bam, bam. What are we left with? We're left with equal, down here, integral of du over 1 plus u squared, which is our definition of integral of 10 inverse of u, or 10 inverse of u is x to the 5th plus e. Okay. So hopefully you guys are okay with this. I didn't cover any even odd ones here, but I did cover a lot of u substitutions and a lot of basic integrals that you need to know. If you have any questions, go ahead and email me just to show you guys the answers in case you need them, because pause it. That's 4, 5, 6, 7. We're jumping that. Go to 10, 11, 12. 16, 17, 18, 19, 20. Again, you can pause the video, look at the answers, just double check. And that's the last one. Okay, you guys have your own worksheets. Let me know again if you have any questions. Thanks.